Welcome to the sixth episode of Nurturing Excellence, Teachers of IIT Kharagpur. Myself, Jayanta Mukhopadhyay, Professor of Computer Science and Engineering Department and Dean of Outreach and Alumni Affairs, will be presenting today a renowned academician and an internationally reputed scientist on geophysics and seismology, Professor Sankar Kumar Nath of the Department of Geology and Geophysics. Professor Nath is an alumnus of our institute. He did his BSc and MSc in 1979 and 1981 respectively, and also PhD in 1993 from the same department. He joined the Department of Geology and Geophysics in 1988, where he is now a professor. He served as the head of this department from 2003 to 2006. He has 40 years of experience in academia and industry in both abroad and in our country. He made a pioneering contribution in seismology, particularly in seismic hazard, vulnerability and risk microzonation of cities of India and also in Alaska, USA. He also made pioneering contributions in developing algorithms for seismic analysis and also developing different techniques of analysis in other areas of geology such as hydrology and hydrophysics. Professor Nath received several awards, including Shanti Swarup Bhatnagar Prize in 2002, Homi J. Bhabha Award in 2004, and several such awards subsequently. He served in several national committees and also chaired committees in areas of seismic vulnerability assessment, and as I mentioned, he contributed in framing the policy and taking measures to handle this kind of hazard. Particularly, he made risk analysis of 40 cities of our country. He also is a member of and fellow of several scientific bodies, including Indian National Academy of Engineering and Indian Geophysical Union, West Bengal Science and Academy of Science and Technology. So he is a very renowned scientist and geophysicist in his areas of domain. So let us listen to his work and life. So Shankar, welcome. So tell me how you have become a geophysicist from your school days. You can tell your story.
Thank you very much, Professor Mukherjee, for inviting me for this discussion session, and that too in a historic location, our institute Shahid Bhavan. This is the arena where we had the martyrs who were shot dead in 1931 by British police, and also this housed many of the freedom fighters who were there. It was the Hijli detention camp, and this is where the first elite institution in science and technology was set up in 1951 by Dr. Bidhan Chandra Roy. And it gives me an intense pleasure to be with you and in this location which I did not visit for last almost 5 years. It was not necessary because we come as and when necessity arises. Well, I wanted to become a space scientist. Physics was my passion. I was good in physics and mathematics, and I used to spend time in solving difficult problems, and I never thought that I will become a geophysicist and an earth scientist. But then whatever you aspire, whatever you dream, everything never becomes successful. Then I got a sea change in my aspiration because a physicist who wanted to be a space scientist and wanted to be in NASA and be a part of the space research in the global arena. I landed up in IIT Kharagpur as a geophysicist, which had become my passion slowly, and I started liking the subject when I took it, because I did not get physics. I did not get mathematics that time. And so I had only two options, either geology or geophysics. So I thought, when it is not possible to go in the sky and in the solar domain, in the exosphere, probably my domain is to go underground and look at what is happening beneath the surface of the earth and what is happening. Maybe we'll reveal the mystery of the universe down below, and in the process harness the resources that is necessary to sustain our civilization. Initially I had some problems. I did not like the subject, and then after first second year, when I started going into the depth of professional subjects, and I started developing my interest in this, and I somehow started loving it, and I mean we became friends, to be more precise, and we got hugely associated, and I took it up as a challenge that I should show something and put my footmark and leave a footprint somewhere, so that I mean at one point of time I should be remembered because for something which I have added up, I have given, and which becomes a value addition to the subject which has been already going on and people are doing, and we had doyens of art scientists. I remembered one of the words of one of my teachers, who is a great mathematician. Though he was not a master's in mathematics, he learnt it through his sheer perseverance.
Who is he?
Professor Devobrata Guho in Hisley High School. So
Hisley
he was
High
a junior technical assistant, junior technical assistant and junior technical trained person, and then he slowly went into mathematics, and then he told me, look, whatever you do.
In Hisley High School?
Hisley High School.
So you studied in Hisley High School?
I studied in Hisley. Actually, my father was in the Southeastern Railways initially for some time, and then he also shifted to IIT Kharagpur as in the accounts department. He was an accounts superintendent. Then in Hisley High School, Guho sir, he was a favorite Guho sir for all of us. He told everybody actually that, look, whatever you become, whatever you do, I mean, there is no recognition for number two. So take up whatever you like, have your passion and have a dream and go ahead, but you have to be numero uno. So I went with it. Then I started cultivating my love for the subject, and I really and then I came in contact with stalwarts in our department. Professor Haigiriwa Rao was my master's dissertation mentor. He was my guide, and he is a theoretical physicist of himself, and he started liking geophysics, and he started working in geophysics, and so he is a theoretical scientist, and he was also an experimental physicist, to be more precise. We had P.K. Bhattacharya. You all know Professor P.K. Bhattacharya. He died very young, and I mean, there was an accident, fire accident, and both he and his wife, they died. But then
I think it is 86?
Yeah. So he was very young, and he was a pioneering geophysicist. Honestly, a physicist and a geophysicist, they have left their legacy even in this short period of span of life. Whatever he has, he could in the department, he did. And we had Professor Khitindra Mohan Naha, who was one of the Shanti Swarup Bhatnagar awardees in our department, as a structural geologist, and Professor Ashok Mukherjee, Professor Shishishan. So all these were the stalwarts, and we were very afraid of them. At the same time, we were following their footsteps, and we were very happy that we have been in one of the departments which is internationally known, internationally famous because of the association of these doyens in earth sciences. That was one of the inspiration, that yes, one day we should be something which will be which will keep the legacy of the department, and we proceed in that direction. So I took it up, and 1981 I graduated. I did my master's in exploration geophysics from this institute, and I was, as Guho sir said, you have to be numero uno. I was number one in the department. and there was a huge difference between number 1 and number 2. And
So what was the trick?
what I used to do is I used to help everybody. I used to, in the whatever used to be done in the class, and after the class is over, we used to sit somewhere and we used to have a total revision. And I used to take the center stage, and I used to do everything, whatever has been done by the professor in the class. And we used to go to a classroom where the blackboard is there, and I used to solve everything once for all. And then I did my master's dissertation in seismic exploration, and also I did some experimentation where we tried to identify surface coupled refracted waves, and those are noises. Later I understood that were the Rayleigh waves, which are noises in seismic exploration, and that mask the data, and we have to eliminate it. And it's sometimes very difficult to remove the air waves, and we have to go for frequency wave number on pi slicing and frequency wave number filtering, because once we get a trend in FK domain, all the events are separated out. Then you understand that this is the event which is a nuisance, and this is a noise, and then you can select the band and you cut it off in the FK domain and bring back.
I mean, you had digital sensors. And
Yes,
those
yes,
things.
we did. I used Philips tweeter and also the entire Philips recording system. So after I completed everything and I appeared for CSI and NET and I qualified it, and then I joined the department. I thought I will do my research, but the problem which I chose those days, it was not very challenging. It was very difficult, computationally intensive, and it was not happening. And going every day, every weekend to Jadavpur, and then booking the slots and all, it was becoming tedious, and I'm doing more non-intellectual jobs and doing intellectually demanding solutions. So I thought maybe this is not the right time or right moment, or maybe this is not the right place where I should. That was the time when I got the fellowship from McGill University, and I had an opportunity to work with Professor Telford, who is a doyen in.
So in which year?
It was immediately in 81, 82. That is the gap. So, and I wrote to Professor Telford, and those days the GRE, TOEFL, and all those things were not that much in vogue. I mean, people were writing it. Then I just wrote. I was just exploring whatever is possible. Then Professor Telford accepted me, and he offered a fellowship. But then there was a family need. My father became sick, and he was hospitalized, and he almost was not being able to pursue his work. So that was the time I appeared for ONGC, because that was the time when ONGC was in full bloom. You know, Professor Cornell Why took over. He was the chairman of ONGC, and every day there was a sort of canvassing going on that we have discovered oil here, discovered oil there, we have struck hydrocarbon in this basin. We have 27 sedimentary basins in India.
Which campus you were there in ONGC?
I joined in Nazira oil field in Assam. So it was only for 1 month I was there, because I did not like the setup, even the environment. And the type of odd jobs that were being allotted to us, it was not a very, intellectual kind. So I was not really enjoying. So that was the time when we got a campus, I should not say it's a full-fledged campus recruitment, but we got a call that there is a company in SIBS, Santa Cruz Electronic Export Processing Zone, in MIDC the colony in Andheri West, and they wanted to take some geophysicists, and so they came here. They shortlisted 5 of us, and then we went for their final interview in Bombay, and 2 of us were selected, myself and Rahul Dasgupta. Unfortunately is no more. He is my classmate. So, and then we joined there. I started looking into the seismic data, and we started digitizing the old ONGC standback data.
So what was the digitization technique?
It was optical scanning.
Optical scanning
we
of
have
the whole document, or because
No,
there are rows of layers of wave patterns. Yeah.
So seismic record is there, and we have the tracers, and they used to trace it on the tracing paper.
Achha.
And that tracing paper you have to push through optical scanner, and then optical scanner used to scan the signal, and then it converts into, it used to convert it into the multiplex format, time sequential format.
So it is basically time series data finally.
Yeah, time series data, but it was chopped up. It was not totally discretized. And I got married in 1983. That was the time when I was still in Bombay. I was working with Indicos, and I went to Intera because we had a collaboration in Intera exploration in Houston and Texas. And they took 4 of us. We went there. We went for advanced seismic data processing training and all. And there was an understanding that after training, and if they like, and if they choose a couple of us, then we probably will continue with Intera and we need not come back. But I thought probably it will be the same kind of situation because we were not handling the actual data and there was no processing. So I came back, and in 83 I got married, and my wife also was with me in Bombay, and we were staying in an apartment, and Rahul used to stay with us initially for some time, and then we were looking for some other opportunities. I then got a call from Oil India Limited. They were looking for geoscientists, and we went for an interview in Delhi, I remember. It was an international center, IIC, India International Center. So it was a written test, and then the normal process of shortlisting, scrutiny and interview. Then 10 of us got selected. I chose their field headquarters in Duliajan, Assam. I participated in developing their first computer data processing computer center in Magsize Computer Center with a CAI computer, and also we have the softwares for data processing. So those days it was housed in Geophysical Data Acquisition and Processing Center. C.V. Subramaniam was the chief engineer of our GDP department, and V.K. Sibbal, who then became later on the chairman and managing director of DGH, Directorate General of Hydrocarbon. So we started working, and I took over the charge of the computer center, and then we did benchmarking of lots of softwares, and that allowed me to go abroad several times, choose the right kind of software, get the software package, and then use the software, and then augment the computation and data processing system altogether. And at the same time, I was also doing data processing myself, because we are a very handful number of geoscientists working there. And at the same time, there was exploration going on in Jaisalmer Basin, Jodhpur, and we used to also have a center in Bay Exploration Project in Bhubaneswar. So we were processing data for Bhubaneswar, and also at the same time.
So how those data came to you? Because that time the networking was not there.
No, it used to be transported.
Big cassettes and all.
This used to come as the pools, and it was 2,400 feet long computer pools. These are the magnetic pools, and these were with the data was 800 bits per inch and 1600 bits per inch, and they were all 9 and 21 track data. All the data used to come in SEGB format. You say Society of Exploration Geophysicists is the governing body for all exploration work, whatever you do, exclusively for seismic exploration. So data used to come in SEGB format from the field, and we used to start processing the data. But there was a huge pressure, because that was the time ONGC and Oil India, they were virtually competing. ONGC had Shivsagar as their headquarters. Nazira oil field also was there, and the entire oil field in the northeast for Oil India Limited, we were producing about 3.2 million tons per year, and ONGC was producing about 2.7 million tons per year, and at the same time they had their major chunk coming from Bombay High, because they had the limestone stone reservoir that is coming from L1, L2, L3 reservoirs, and they are still producing. And then we also started looking at the Bengal Basin data, because the ONGC gave us the data, and they were having some problems because that time GeoPeak was not there. So some part of the data also we were processing, because they did not have any data processing center in Northeast. So we virtually started working in collaboration. That was the time we discovered 3 oil fields in Assam, Naharkotia oil field, then Sapekati oil field, and also the North Lakhimpur oil field. So I participated in this as a seismic data processing individual, and that was one of the achievements I had and I can boast of. And at the same time, we also struck 2 oil fields in Arunachal Pradesh. So a lot of efforts, a lot of things were happening. People were working on enhanced oil recovery technique. Then 3D seismic exploration has come, and even the 4D and 4C seismic exploration also start, because once you start producing and the reservoir has started flowing and the hydrocarbon is being pulled up, so you have to monitor the pressure inside. So we used to repeat the 3D survey with time and used to see what exactly is happening to the oil pool. Where the pressure is falling, what is the direction of the flow, and so on and so forth.
What is the impact? I mean, what are the
what happens is, by doing this, you can understand that somewhere if the pressure falls, then you know that you have to go for enhanced recovery technique, and you might have to flush up the reservoir to.
Will there be any hazards or
not
danger for that is not there?
No, it is not there.
It is based on the efficiency of your getting oil,
yes,
recovering oil from
correct.
those wells.
So in order to have a sustained flow of hydrocarbon coming out, so if you have to keep on doing enhanced recovery, apply enhanced recovery technique and flush up the oil, so that the oil pool remains almost with the same pressures and the flow remains almost continuous.
This technology, say you started with, I should say, late 80s, for example.
Yeah.
And now you are the second decade of this 21st century. So how this technology has become? I mean, what is the state now?
See, the problem is the aquifers, or when we go for groundwater, the aquifers were very easy to find. The reservoirs which were in tertiary reservoirs, they are getting almost depleted, because we have been exploiting hydrocarbon for so long. Now the reservoirs are becoming more trickier because we have disseminated oil. Earlier we used to have the oil pool. We go do the exploration, we get the reservoir, we go for further exploration and then go for production and then start producing. Now you have the oil which is disseminated. So what we are doing is we are using secondary enhanced technique, where we are injecting bacteria. We are also using nuclear fission to break the chain, and so that all the oil from these disseminated bodies, they come and they make a pool. So the exploration is becoming more trickier, and we are getting the tertiary is almost getting over. Now a generation will come when we will be looking at the Paleozoic and Mesozoic, and they will be below the Deccan volcanics. And you know the Deccan volcanics is about 1.5 to 2 kilometer thick. So crossing that and then pushing energy inside up to a depth of about 10 to 15 kilometer below the Deccan volcanics, and so that you reach the Mesozoic and Paleozoic sediments, which are also carboniferous. It will be very difficult. Now the magnetotelluric survey has come, because seismic fails, because it is not possible to penetrate these Deccan volcanics, which are very thick, and then reaching. So this is a future source of energy, future source of hydrocarbon. Also at the same time, you must have heard gas hydrates. The gas hydrates, oil. India is one of the 4 major nations who has got a huge gas hydrate reserve. The gas hydrate exploration is also done through seismic. We call it these are all in the
gas hydrate is a natural gas.
Yeah, it is a natural gas. Methane, which is entrapped in water molecule at about 300 to 400 fathom depth, and at a very high pressure, low temperature condition. So therefore, so you have it. We have a bottom similarity reflector that is also a reflector. So once we do the exploration of all the coastal regions, and we can find out, because Andaman is one region where we have the gas hydrate, and there are gas hydrates in KG Basin. There are gas hydrates in one of the. So we have all these basins which are having gas hydrates. Now we have explored it, but the problem is that once you get gas hydrate on the surface, immediately it comes to high temperature and low pressure conditions. So it releases the gas, and it breaks. So you cannot, so it's still so far, harnessing methane from gas hydrate is a problem. It is still, I mean, there are research going on how to produce.
We cannot use it.
No, it is still not under production.
But what is that natural gas they are drawing? That's a different thing.
That is natural gas which is coming from the reservoir.
That is a different
That is different. My industrial exposure has given me very good understanding of the wave propagation phenomena, how it is working and what is happening. But at the end of the day, what am I doing there? I am only producing seismic sections. I am getting the data, and we are not, and whatever problems we have, we are relying on our foreign collaborators or the overseas collaborators to give the solution, and then the data. At the end of the data, at the end of the exploration, the data, most of it, sometimes we send it to Singapore for further processing, advanced processing, or we send it to Houston where Western Geophysical is sitting over there.
On outside
we did not have the
even equipment and analysis both.
So we were virtually doing sort of routine data acquisition, routine data processing, and
using
so
their
on.
techniques, you are just observing.
We hardly if you look at the international companies, the companies who are the vendors who are sitting in Houston and they are sitting in California or they are sitting elsewhere, they are also solving these problems and they are publishing papers. So there are some intellectual value addition from their side, and they were also doing research impact. And some of them are publishing papers in high impact factor journals. But in Indian condition, we hardly have that kind of publications coming from the industry. And what are the industries we have? We have Oil India Limited, we have ONGC. So when I was not...
So they did not invest research initially?
No, not much of research was going on, because they have, their main agenda is...
To get oil.
Get oil. And when Colonel Wahi was the chairman, that was the time their only aim was go, hit, get oil and get the oil. That's very important, because we are still, our requirement was about 300 million tons per year. We are hardly producing in-house, not even 60 to 70 million tons. So we started doing it, and that was the time when I was in Houston. I was with Seismograph Services Incorporated, and I was doing benchmarking for deep move out software. And at the same time, I suddenly saw an ad that the IIT is looking for the faculty positions, and then I talked to the head of the department. That was the time Professor Dilip Sengupta, he was the head. So I called him. I said, sir, I was in Houston that time. I said, sir, should I send an application? I don't have a PhD. I am still working. He said, yes. And I also told him that, sir, there is a mention that if you have about 7 years of professional experience, then PhD is not a must. So then he said, you apply. So I sent my application, and knowing that I probably will not be even getting an opportunity to even go for an interaction. So I was fine. I was doing my job, and suddenly I got a call, and that was the time when there was no Skype or there is no video virtual interview. So I was called for an interaction. I came, and Professor Chopra was the director, and the board was an elite board. We had Mr. Talukdar, the member exploration of ONGC. He was there. Professor Binod Gaur was also sitting there. They're all, they are doyens in their own field, and the names we always remember in the morning. The first thing we do is that we remember them and start the day. So these are, and Professor Shubir Ghosh from Jadavpur University, he was a well-known structural geologist, and he's also a Bhatnagar awardee. Professor Gaur also had been a Bhatnagar awardee, and so all of them, this was an elite board. I was the last candidate called for the interview. Before me, there were many candidates were there, and all of them had their PhD. They were all going through with their PhD thesis, and I had nothing to go. I just, whatever I did, I brought sort of a synopsis about 10 pages, and it was in around 7:30 in the evening, and they were going for a cup of tea, and Mr. Dash was in the establishment section. He was handling the whole thing. He told me to fill up the TADA form and all. I said, I have spent about 8 rupees coming from Kolkata to Kharagpur, and you will not give me 40,000 which I spent for coming, and again I have to go back. So thank you very much. So I give it to Brotherhood Fund. So I sent it. So I went in, and then Professor Chopra, Mr. Talukdar used to know me because I used to process a lot of data when I was in ONGC, and he was in Dehradun. So we used to go and And then he says, well, how come you are here? I said, sir, I wanted to come back to the academics and all. Then usual questions started, and Professor Gaur, as a usual teacher, then he started going into signal processing and linear, non-linear signal processing and all, even geophysical inversion, and he asked me to even write the equations and all. So the interview went for about 1.5 hours.
From
7:30, 8:30 it went on, and they had tea and all, and I was very unfortunate that I did not even get a cup of tea. That was it.
Protocol.
The protocol. So the interview went on, and it went on. The grilling was havoc. And Professor Chopra told me, look, you don't have a PhD, so how much time would you need? I said, sir, I have everything. I am coming from industry. I have the data. I know what is to be done. I have this zeal, enthusiasm, and I will do my best to finish it at the earliest, because I will be otherwise sufferer. Then he said, gentlemen, I can give you the maximum 5 to 6 increments. And will you be joining, and how many weeks or months you need? I said, no, sir, I will join at the earliest. As soon as my assignment, whatever I have taken up, I finish it, because I just cannot leave the company in the lurch and come back and join here. It's not possible. So somehow I got a hint that, they are very satisfied with my interview and all. And I came back, and I was looking at the other candidates. They were all still sitting over there. And looking at their face and all, I could make out that they did not enjoy the way I enjoyed it. It was fine, 1.5 hours, and I was very contented. I went back and I got the offer. I came back. I joined in 1988. It was 25th of August. And when I got the offer, I was still in Houston. So Professor Shishi Sen was the Dean of Faculty that time in the institute, and Professor Shishir Mukherjee was the Dean Academic Affairs. So we had 2 deans from the department. So I met Professor Shishir Sen, and I said, sir, can you give me 21 days, and if it is possible? He said, no issue. But no more than 21 days, because we need a person. Semester is starting, and you have to come and start taking the classes. We don't have a person to teach seismics. So I came. Once I came and I joined, immediately I have been given about a load of about 10 hours.
That is natural.
I was given general geophysics, and that was, and I started teaching seismics, because we suffered, because we did not have a professional seismologist to teach. Professor D.K. Ganguly was teaching us seismic prospecting and all. And seismology was being taught by Professor Haigibarao. They were all good teachers. They were very nice. But the professional exploration seismology was not there, suffering. So I took it up. And I started teaching. I don't know, in the process of doing that, slowly and slowly I became very close to the students, and being very young, at one point of time I had the entire batch of students. They wanted to do their master's dissertation with me. I took all of them. We did. It was a good start. I was very happy, and immediately I also enrolled for my PhD. And I took Professor Shopar Majumdar. Professor Shopar Majumdar is a doyen of structural engineering. The Mandakini Majumdar, Shopar Majumdar. They were stalwarts. So I met him, sir, I can do something with using your technology. Is it possible to do something new? Then he said, why not you do finite element modeling, because that gives a holistic modeling of the entire subspace. Finite difference is a node to node variation, and you go with the nodal coordinates and nodal variation of the responses. So I started, and he said, you have to attend classes and you have to learn. So with 10 hours of teaching, I was attending his advanced structural engineering classes with MTech students. So I developed 2-dimensional seismic modeling in finite element and 3-dimension. But what is new in that? I developed 2 things which are very important. How to incorporate boundary conditions, the absorbing boundary conditions, because our prototype is huge, is an infinite domain. You start with the surface of the earth, and then the earth is its infinity is the limit. So then we introduced an infinite element, so that at infinite element, the display, it is basically is an isoparametric element I have used, and where both the displacement and the coordinate, they are transformed similarly. From the global domain, you go to the local domain, solve the equation in the local domain, and you are basically solving a global equation of equilibrium of the type mass into acceleration. Is a very simple global equation. Mass into acceleration plus the damping factor into the velocity, because damping goes with the, it's a viscous damping, plus stiffness goes with the displacement, and equal to the vibration or the harmonic force you are giving. So I am basically solving it, and we are developing the graphics routines and the graphic user interface on the HP, and I was writing my code in HP UX environment, and was writing Visual C++ coding and all. So, and this has been used successfully, and this was published in very high impact factor Elsevier and Pergamon Press journals, and this has been given to the industry. So and that also earned me my PhD, and I immediately became assistant professor in 1993 as per our agreement during our interview when I went. And then my journey actually has started, and I started liking my intellectual hunger is coming and getting quenched slowly and slowly.
How did you come to this earthquake
Yeah,
analysis?
this I'm telling you, because this is my life. See, I have a 42 years of professional experience, Professor Mukhopadhyay. So you can understand, I came through so many things, and I kept on changing my domain. And geophysics is a multifaceted subject, and earth science is a multifaceted domain, and it gives you enormous domain to work. And you can keep on changing your paradigm shift, and you can go into different domains. So when I was doing this, Professor Haripodo Patro in our department, he was an electrical prospecting person. Professor Amit Patro, our present deputy director's father. So he was also my teacher, and he was a stalwart, and he was also a doyen in exploration, is electrical exploration. So he was having some problems. He said, Shankar, I have a problem because in my electrical prospecting, we have an equivalence and suppression problem. The equivalence is that the same layer having the resistivity and thickness combination, for the same problem, you have multi-solution. If rho into H, a rho 1 H1 is the same as rho 2 H2, so you have two solutions. If rho 2 into H3 is same, so same problem will have multi-solution. How to solve this? How to handle this? Then I said there is a way of doing it. I was also working in seismic refraction because I was taking my students to the field, and since we have a reflection of the problem, so we used to have a very constrained source and constrained domain seismic exploration as a field investigation training for our students. So I started developing a code for exploration, interpretation of seismic refraction data. As I told you, that once we are having a source and it hits, we have a reflection, and if the angle of incidence reaches the critical angle, then we have a refraction coming. So this refraction is a supersonic wave. This supersonic wave will be also coming back to the surface of the earth as a head wave. So if you track these head waves and these will be the primary arrivals, the reflections will be the lateral arrivals. So you have a direct wave which is going along the surface of the earth, you have the head wave coming in, and since the head wave is coming with the velocity of the next layer grazing the interface, so if you can track the critical distance and the critical point, then if you know that the first critical point will give you the notion about the first layer, then you downward continue yourself and reduce the data by taking the plane of reference to the first layer. Then start looking at the second layer. So you solve the problem by downward continuing this and refraction. And what was happening? What is the data we are getting? What are the parameters we are getting? We are getting the velocity, the interval velocity of each and every stratum, and the thickness. What Professor Patra was getting? He was getting resistivity and the thickness. So if we tag up thickness, and if my resistivity and velocity can be sequentially inverted with respect to each other, I use seismic refraction data to guide his inversion, and his velocity, his resistivity helps me to guide my solution. So Professor Patro and me, we collaborated. So he says that let us submit a project. He said, I never wrote a project in my lifetime. I said, sir, let us submit. This is a very nice problem. Let us submit. So we submitted a small project to CSIR. So, and I went to defend, and we both went, and it was well acclaimed, and we got the project. We gave a project for only 3 lakh, and they expanded it to 10 lakh. They gave us, and we solved, and I developed 3 computer packages, a SciSRes, It all published in Computers and Geosciences and Computers and Structures. And these helped us in solving groundwater problem. The identification of aquifers. There are some tricky aquifers which you cannot identify unless and until you have this kind of joint inversion, because they go hidden. So therefore, and in this, especially in hard rock terrain, in soft rock terrain you get it, but in a hard rock terrain where are fractured reservoirs, there are fractured groundwater aquifers and the fissures, how will you identify them? There we use this, and at the same time we went into generating the other geological attributes like the drainage density, also the topography, and all these along with the seismic parameters, seismic attributes and the electrical attributes, we integrated it using a heuristic technique, and we went into, those days there was no concept of machine learning, but we used neural network that time, and I used genetic algorithm to have a global optimization of the inversion. Otherwise we have the problem of...
In which year you did this thing?
This was in 1997, 98.
Okay.
And at the same time, I was also started working with Professor Shopan Majumdar, and as we started working for Gammon India Limited and the border roads, and we are going to Arunachal Pradesh, the inaccessible territories, and to get the foundations identified for
assessment of foundations,
because the border roads has to have the dam constructed, the bridges, and also we started doing even consultancy services. So when these things was going on, if you remember that in 1975 we had the Chashnala disaster, and you know how many miners died. So that was the time when Coal India Limited, they floated a tender for doing identifying the galleries, the voids in the Raniganj coalfield, and also the Dhanbad collieries, the Asansol, Dhanbad, and Raniganj, and that belt. I thought, can we do something on this? That time Professor Ajay Rai was in electronics, he was there, and he was also working on genetic algorithm also, and I also started working genetic algorithm, evolutionary programming, and neural network in inversion of combined geophysical and the electrical data. So then I talked to Ajay. They say that I cannot participate in these things, and you can, but then I can, whenever, as and when you have a problem, we can discuss how to. Then I thought, let me try this. Then we competed. So we got a pilot project first. So what we did was, we generated a forward modeling algorithm by using the principle of reciprocity and dynamic programming approach.
So you have solved this problem.
We solved this problem.
And it is applied.
It is applied, and we also, not only that, we got a huge project, and this project gave me the first hands-on on the seismic exploration. This is still a seismic exploration, hands-on expertise, and at the same time my footprint in the sponsored research and industrial consultancy as a good project, and it was also published, and it was done. So we used also neural network for pattern recognition. 2000, it was 1999, 2000. So all this, this has totally given a non-unique, complete unique solution. All non-uniqueness, ambiguity, everything was removed. So it was, and this earned me my first award, National Mineral Award by the Ministry of Mines, and so. And till that time I did not know that you can get awards and all this. I was only working, and I was very happy with my teaching, research, getting projects and funding, and I actually have become almost a professional academician. And with my industry background, I was behaving more like a professional than an academician, because my goal was that in a short time I have to achieve something, and don't remain in that subject forever. So I started embarking on intellectually demanding, societally required projects, and which were vitally required at that particular time. 2000, it was continuing. In 2000, there was a problem again from ONGC. They asked, they were looking for somebody who can look at the thin bed stratigraphy. I told you that a reservoir comprises of Digboy oil field. You have heard of Digboy oil field. It was discovered by an elephant in 1889, and this is still producing.
You know Narayana Mukhopadhyay's story?
Yeah.
So So it's of course comment.
Yeah.
So they said that no elephant walked and they get oil footprint.
Yeah, and then once the Britishers actually
So how elephant discovered
yeah, actually
that?
what happened was that their exploration was going on, and that was then Robin Mittir. He was the geologist, and Percy Evans. They were the the gods of I should say of the Northeast Indian geology.
Okay.
So they were all sitting in the camp and all the exploration going on, and they have the elephants to carry all the equipments and everything. Suddenly, one of the exploration geophysicists was sitting over there. He was looking at the paws of the elephant, and he saw that there's some paws mark everywhere. They went and they said it is viscous. How it is viscous? That means there is some seepage going on somewhere. Then they started
So it is
looking
true
at
then. It's an oily footprint.
Yeah, it was a footprint, and it was from
I thought
the paws.
that it is just a comic story.
No, it is not. It is not. It is truly. And then they went and said, and then the next day they started digging. They said just drilling itself, because whenever you are doing exploration, when I am doing exploration
But
at the same time there are.
Does it happen? I mean, the oil is so below the surface that we
no,
get.
See, it is actually it is a huge oil pool. You know, it is a huge reservoir. It has 100 oil sands. Each oil sand is about 10 to 15 to 20 meter thick. So you can understand it is about 3 kilometer thick reservoir, and it was in Girujan clay and sand, and it was basically is the Tipam sandstone. So this we have a Tipam and Beryl sandstone, both were producing, and it was actually seeping. There was a seepage coming on. So they started looking around and they saw, and there's a dig buoy. So from this dig buoy, boys dig. So from this dig buoy, so they named it as a dig buoy oil field, and it is still oozing oil. They have removed, they are not producing oil, but they are allowing the reservoir to slowly come down, and it has to have its own natural death. So it is still producing 0.45 kiloliters per day, and the villagers come, they collect oil and take. Now it is just
in world also this kind of oil.
Yeah. But you have to allow it to naturally
in world
die.
there are
many. And then when you say there is a problem, we are not being able to identify the thin beds. What to do? Then since I had a collaboration with WinGC that time, I was in Oil India Limited. Then this problem was given to Oil India, and they contacted us and can you do something? Then I said okay, we use fractal analysis there, because if you have, and we used nonlinear signal processing, we used into empirical mode decomposition to get all the intrinsic modes coming out of it, and these modes, when we go into fractal dimension analysis by using line divider and Haas method, you know that all these, and the seismic signal in a very thin bed, which is so thin that you cannot, it is there but you cannot identify. Then if you do,
so you are basically computing fractal dimensions.
Fractal dimensions. I was computing fractal dimension of this signal's attribute. What I did, I immediately went into Hilbert and divided this into instantaneous frequency, instantaneous phase, instantaneous amplitude. It is the instantaneous phase, sometimes it gives very good result. Instantaneous frequency gives very good result. So I was trying fractal dimension analysis on this.
You were successful there.
Yeah, very good. We had a fantastic results, and this was published in Geophysical Prospecting, and
is it used still, this kind of technique?
Yeah, it is. And this is big. I have given everything to them and they're using it. Suddenly Latur earthquake came. The earthquakes were happening all over the globe, but I was not interested because I am an exploration person. I did not have much of an interest in going into earthquake and all these things. It triggered, it was about 6 point odd, about 3 or 4, but 2,000 people died. Then I thought, what the hell I am doing? Should I, because the wave propagation phenomenon and the wave kinematics is the same. So if I know the mathematics and the physics of the wave kinematics, why not I try to do something, and I try and see whether I can participate in this issue. Then I went, visited the place, and I went for almost for 1 year or 2 years. There had been continuous discussions and going on all over India, then what to do, how to handle, what kind of problems we should solve and all, because this was, you know why? Because Latur is a peninsular shield region which was supposed to be quiet and it was stable. So it was and that was the time when the seismic zonation map of India the Bureau of Indian Standard has published a seismic zonation map of India, and we had 5 seismic zones. And then they, after Latur earthquake, they removed zone 1. So we started having zone 2, 3, 4 and 5. Now we have 4 zones. 1 is gone because not a single place is now non-seismogenic. So all this was happening, and then I was thinking that I should participate. Then I started going into almost all the seminars, workshop and whatever. And whenever they used to come, the head of the department used to ask who wants to go, and all I used to go. And small amount of seed money we used to get from here. So anyway, so I in the process of these discussions with the Department of Science and Technology and the India Meteorological Departments and all, then I thought that let me also looking at it. Now earthquake has got 3 issues. One is that you have a source from where the faulting takes place, and once the faulting takes place, it is in exploration we do constrained source seismic imaging. Here it is a natural source. The energy release is very high. It will be some raised to 10 raised to 15 or 16 ergs or joule, and this will be of the order of, if it is a magnitude 5, you will have an earthquake of which releases an energy of the order of about couple of 2 or 3 atom bomb. So this amount of energy it releases. 5
in the Richter scale, you are saying.
Yeah, and then what if it happens? Then wave starts propagating in, and this goes through a media, the whole of the earth. So you have one problem is to understand the source, and when the wave is propagating, you have a problem. You can image the subsurface by tracking these waves, and then you have a site where you have a recorder and the detector, the seismometer, which has been sitting over there, and it records it. So you have 3 problems. Either you look at the source and try to understand, you become a source seismologist and work on it. You also have you can become a tomographer and CAT scan the subsurface and try to see what is the depth of the moho, what is the depth of the. Now the problem which I solved for Raniganj coalfield or Asansol coalfield, and the problem which I solved for all these, now the domain is becoming bigger. The problem remains similar, the problem remains same, but it is becoming bigger. It was 1 kilometer, 2 kilometer, now it has become up to from 0 at the surface of the earth to 6,371 kilometer to the center of the earth. The radius of the earth is 6,371 kilometer. So that is the domain you are working, and the wave will be propagating. P will not be P. If it comes and hits the moho, then it gets another phase, then it goes out, it will be another phase. So all these phases are coming, and you record it. Once you have a seismic record, you can study all these events. From these events you can do the imaging of the subsurface of the earth. And the other one is, if the earth, all this goes to the surface of the earth in the first 100 or 300 meter depth, that is the engineering bedrock. So we have a seismic domain, we have an engineering domain where it comes, hits, and all the urbanization, urban structures, everything, all the civilization, whatever is there, they get damaged, devastated. So you have 3 or 4 domains where you can work. Then the site, when you come to the site and the urban structures and all the civilization, that is something where the participation of the seismologists, it was the domain where earthquake engineers and the structural engineers are working. But they do not have the good understanding of seismic wave propagation. So they do it some sort of a thumb rule and do it. And if we try to do what they are doing, then we will not be, because I am not an engineering person. So how to marry both?
Complement.
And complement it. Then I formed a group here, and Professor Sriman Bhattacharya, then Nidjar, and Debashish joined that time, Debashish Roy, who is a geotechnical earthquake engineer. Then we formed a group, and also we have from architecture we have Uttam Banerjee, so we have formed a band. That is the time Ministry of Home Affairs, they were floating an earthquake engineering education in India. Then they were giving fund, and 5 IITs are to take the call, and they have to take they should be the host. Then in the institute, who will be the host? Because we formed and they wanted from all the departments, and who will be the person who will be the nodal person. Then fortunately or unfortunately, or maybe it was my destiny that I finally go into earthquake domain and I start working on it, I was made the nodal coordinator and this was our group. So I participated. They said that look, if you want to go and work, slowly I saw that the funds are coming and we should also develop something, and IIT Kharagpur does not have even we were doing theoretical seismology, there is no earthquake related work. So when I went to, so it was basically happening between 1990, 91, 92, 93 and then 1991 Uttarkashi, 1996 Jabalpur, and then 2001 the Bhuj earthquake took place. So when 1993 occurred, then I was thinking of submitting a project. So I went to DST. They said that one project which you can try is go for strong motion seismology. Strong motion seismology, everybody is basically having observatories all over, but the Himalayas, they don't have the strong motion, the accelerographs. So what do? You study the strong motion, the earthquakes which will be studying with magnitude 5 and above, and using those we can do site characterization, site response. So if a wave comes here, if the wave comes and as soon as it hits the engineering bedrock, what is the amplification of the ground motion? If this amplification and the predominant frequency matches the predominant frequency of those building structures, there will be resonance, and because of the resonance, these structures will fall, there will be collapse, their buildings will be damaged, and so on and so forth. So once this was happening, so my first project came in I wrote my project in 1995, and that was the time I got an opportunity to work with Professor Niren Biswas in Alaska Seismological Observatory in Geophysical Institute, University of Alaska, Fairbanks. And there I learned the strong motion seismology and also seismic microzonation of Anchorage, because 1964 Prince William Sound earthquake has removed all the installations in Anchorage, and there was a liquefaction. So I embarked upon seismic microzonation as a new subject, and the strong motion seismology was something which the competition was less. So I went in, I gave my first project, I got a project which was worth of several crores. I got 16 stations to be installed in the Darjeeling Sikkim Himalaya.
When this project came?
It came in 1995, 96, that was the time. The project came in 1996. And so from during 96 and 97, I started laying out the observatories, strong motion network in the Darjeeling Sikkim Himalaya, because this is the domain where nobody works. So the Himalayan domain, there was no everybody is working in Uttarkashi, some people are working in northwest Himalaya, but in northeast Himalaya, there is none. So I started then working on that. At the same time, since I learned microzonation, I brought in the concept of microzonation, and the first microzonation we did was in Sikkim Himalaya, and that was
which year?
That was in 97, 98.
So now you are heading also the committee.
Yeah, I am
microzonation.
Yes, I'm still. We had a national steering committee, and I framed the seismic microzonation. Everybody was doing microzonation, but there was no protocol. So what we did, I was given a responsibility that you come up with a protocol, have a handbook ready. So I wrote a handbook. There was a committee. The committee vetted it, and then it was published by Ministry of Arts Sciences.
In which year?
It was in 2011 and 2012, and then at the same time, people will not read that 700-page volume. So they said that why don't you write a manual and give it to them? So I wrote a manual also, and simultaneously it was all released by Bilasrao Deshmukhji in 2013 in Anusandhan Bhavan and CSIR, and it was with funfair, and the protocol is given. I took up microzonation of Kolkata. I finished it between 2011 and 2016.
So how risky is Kolkata? Tell us.
Kolkata has got about, actually Kolkata has been put between zone 3 and 4. So what is the utility of this microzonation? So this utility of this microzone, there are about 7-8 locations where in central Kolkata, the south Kolkata, the north Kolkata, we have identified locations, and where we have said that these are the places which needs retrofitting of the older structures, including the heritage structures. So with this, what is happening is, even though we have 4 seismic zones, each seismic zone, if we go, so with this concept, if we go, so what is happening? If we consider that the city is in zone 3, we have different bylaw. If it is 4, we have a different bylaw. So if you cross from one bylaw to the other and you jump to, what will be the cost escalation? It will be 10 to 15 times. But if we judiciously use the same money and in the same zone, if we microzone it, and wherever we need more money for urbanization, self-urbanization, spend it. Wherever we don't there is no necessity of going for the higher bylaw.
Yeah, yeah.
So therefore, the
that's
National Steering Committee of Ministry of Arts Science was formed. There was another body came up in the NDMA, National Disaster Management Authority. There was another group. So there was a competition between our group and their group. They were also writing handbook, manual, but before they did, we published it, we circulated it, so there was a problem. Professor T.G. Sitaram was heading that group. Professor T.G. Sitaram is
But
the
finally,
director.
I think both of you collaborated.
We collaborated. We have been very good friends.
Very good friend.
And my dream that I have few more years left before I lay off my office, and before that I want to produce the microzonation of almost all the capital cities of India and give the probabilistic seismic hazard, vulnerability and risk and damage potential modeling. We are also
So how many cities are left? You have done 40
there are
around.
64 cities we have identified in the National Steering Committee,
So
of which
24 are left. now.
people are already working. There are they have given tenders. Some people are working with the as on bidding, and we are working on research mode. So by the time I finish everything and all my students will graduate and I lay off my office, the second generation or the third generation probabilistic seismic hazard map of India at the surface consistent level, because that is where the damage occurs. The damage potential model of all the cities which are in zone 3, 4 and 5, and with the a population more than 1 million, all will be microzoned and all will be reported. So this is with this I will complete
it's
all
really
this.
great to know that it's such a I mean the deep expertise and also the dedication and your vision. That what you are saying, that means that you have a mission and vision for your life and you are carrying it out.
I got many offers for administrative positions also, but then I thought that the research administration and my kind of research, where my motivation, my dedication goes deep into, and I spend time with the students even now. The way I have been working, I still have a lot of dreams. I have many enthusiasm. I am a very hardcore.
So who is the most influential person? I mean, other than your parents, who is the most influential?
Well, I should say that I have influenced myself, but I have many well-wishers. I got Professor Binod Gaur, who has mentored me and helped me a lot. I have Professor Harsh Gupta. They're all still living, and they're the legends in all this. And then at the same time, I have my colleagues in the department who helped me, and my teachers, they helped me. And settling down, I did not go to. I also got selected in ISM Dhanbad that time. It was not IIT, it was ISM Dhanbad. But then I said, if I have to do something, I have to put my footmark. I will put it in the footmark of this department where we already had doyens of art sciences, and maybe I will join them, and maybe the herd will be more stronger. And then they all helped me to settle down. I never had any issues. I am very happy with my students. They were very dedicated, and everybody said I am a very hard taskmaster. My students are very dedicated and motivated, and the things are all going fine. And my wife participated. She gave a huge support, and because for last 15 years probably I did not even go for vegetable shopping or everything. She does everything. She was doing everything, except during this pandemic time when I had to go and I have to do this. And we have only one daughter who is also settled in Toronto. She herself and her husband, they were all electronics engineers turned graduate entrepreneurs. They did executive MBA from IIM Bangalore. They are electronics engineers from Vellore. And then my son-in-law Arnab did his MS in computer science from Georgia Tech. My daughter, she continued in Urbana-Champaign, Illinois, Urbana-Champaign. She did her advanced MBA, and then both are in Cisco. They had been in Cisco in Bangalore. They are still in Cisco. They were initially in Dallas and then shifted to Toronto. They are still working there, and we are planning to visit them maybe in December end. I'll be going for a couple of days, and my wife will spend some more time. So this is how things are happening.
It's great to know all about your work and also a little bit of glimpse of your life that you gave at the end to us. So just before we conclude, any message to all your, so you are very senior researcher, to all of us right now who would like to do research, and any kind of message even for the youngsters who are doing.
You have to love what you are doing, and if you do not find any interest, you don't do any mechanical work, because mechanical work will not give you the final achievement. you have to go to the zenith of your success. The only way is hard work, dedicated work, enthusiasm, dedication, eat good food, and you totally get into this subject and work. And don't give your students and tell them, look, this is the problem you solve, come back to me. You have to also independently think. I give the solutions of almost all the problems to my students. They also think. They come up with a solution, they give the solution. Finally, whatever is acceptable, we accept it. It may be, and sometimes some of them they gave very good inclination. Sometimes I did. So it was basically you have to get into the problem. But if you sway around in too many things, you are doing administration, you are doing this, you are doing in everything.
Focused. You have to be very focused.
You have to dedicate yourself in one thing and finally go into the core of it, and you have to get what is to be done and go to the zenith of your success. But I am very happy that I was not in industry. I came back, and so I have a flavor of both academia and industry, and I am a successful industrial professional and a successful academician. I have done whatever I could with whatever resources I could generate, and maybe this is what was my destiny, and I achieved whatever I could, and I am very happy person, and I am really grateful to you that even though it is late, because in 2002 I got my Shanti Swarup Bhatnagar award, and I remember that that next year when
see Sankar, we are grateful to you because you came here and you did such a wonderful work. We all listened to your work. We know that you are one of the pioneers in earthquake
Thank you so much.
and
Thank you so much.
So thanks.
Thank you so much for
program.
inviting me, and I am really grateful to you, your team, and it has been really great. And this is the first time I saw 5:30 in the morning, because I am a late riser, because I go to sleep around 2:30 and then I get up a bit late. So my day starts at around 7:30. So thank you very much. Thanks to all your technical support, and to Arnab and others. Really it has been a concept which you have conceived to get all the Bhatnagar awardees and taking their interview, trying to see what they have done, how they have come up to this. I remember when Professor Mashalkar was the DG that time, during our Shanti Swarup Bhatnagar award ceremony in 2003, 12 July it was, in the Bigyan Bhavan, and in the night they have given a Bhatnagar laureate dinner. So he told my daughter, you know now why your father was not in home in the night. And he told my wife, you know why your husband was not was coming at early hours, and he was not in so you have understood what he has been doing. So he was not cheating anybody. He has done what he has done for the country, for you, for all of us. So we have to have the generations coming up like this. And then he thanked them for their sacrifices, because I could not give my daughter what she deserved to from her father. My wife also could not get what she deserved from her husband. So to that extent, I don't know how much successful I am. But then at the end of the day, if I look at it, then I see there is a holistic achievement all over. And I will be going from here in another couple of years, but I will be going with a lot of good memories, and we have good friends like you, and there had been very good colleagues all around, and they have been very supportive, because sometimes we come across severe crisis, sometimes because of many things, but then they always extended support and we came out of it. So thank you so much.
Thanks
for everything. I hope that this journey goes and gets successful, and you'll land up somewhere. And all my best wishes to everybody, all my junior colleagues, all the next generation, that be patient, have perseverance, do what you are doing. Don't see and don't get the result immediately. There is no shortcut route to success. It takes time, but success will come, and once it comes, it will come with thumping achievements. It will be really glorified.
Thanks.
Thank you so much. Namaskar.